Now we've reached the point in our model where we can actually start to think about getting prepared for the least cost path analysis by creating the resistance surface. So we're creating essentially that site suitability model where it's suitable for me to hike or not. So in this case, we're looking at my preference in terms of cost. What do I prefer? If you're looking at migration path, you might be looking at risk or something like that. But we're creating that surface to understand where, that'll help us understand where's the best place for me to hike or for the deer to migrate. So we need to look up that raster calculator tool and add that in. And if this looks a little bit different than you last saw, it's just because I hit the auto layout. Now for our raster calculator, all of our inputs are going to be the outputs from our previous tools. So we'll draw each of them in as an input, and then we'll have to address it here anyway, but I like to have the arrows already drawn. All right, so we're going to go back to my criteria table. We already did this part where we ranked within the criteria in terms of which is my most preferred. Now we have to do this last part. We have to rank among them or between them. So we're going to keep this just like we did in our suitability analysis for simplicity and for you to go back and see, repeat that again. How important they are to the overall analysis. So how important they are to my preference. I'm ranking them 1 to 3 as I did before, just to keep it simple and uncomplicated. And this is the ranking I decided on, that land cover was most important, followed by slope and public ownership, and lastly trails. Mostly because there just weren't a ton of trails, so I knew that if I put too much weight on this, it would be really difficult to actually find a good path. Now, to get our percent weight, if you remember from site suitability, it's the relative weight for a layer is equal to 100 divided by the product of the sum of all rankings times the ranking for that layer. So what does that look like? We add together all the assigned ranks to get 8. We use 100 divided by the sum of all rankings. So 100 divided by 8 times 3. So 100 divided by 8 is 100 divided by 8 is 12.5. So then we would multiply it by 1 for trails, multiply it by 3 to get 37.5 for land cover, and 2 for slope and public ownership to get 25. That all equals 100. We then multiply, or move the decimal point 2 places to the left, divide by 100 to get our multiplier that equals 1. And that's covered a lot in the site suitability analysis, so I won't spend too much time here. But we want to take basically build that math in. So I need to pull this table to my other screen. And I'm going to create that expression and then show it to you. Okay, so I have calculated this out. I'm getting errors. It's telling me I'm missing something. Let's see if it says what it is. Syntax, unexpected end of line. So we're missing something here. Okay, well it's gone now. I don't know. It may have been left over. So I'm going to rename this Raster Calc 1. We'll go ahead and click OK. I'm going to make sure my arrows are still lining up. Click on that auto layout because it makes me happy. And then, okay, so see how this Trails reclass is now, doesn't have the drop shadow. We're going to have to rerun this so it has that Trails data. Because if we just ran it, it would tell us like something wasn't working right. I'm also going, well, no, we're just going to go ahead and run this and look at our outputs. Okay, we'll go ahead and add that to our map. Add to our display. Let's close this. And we can see now that we have values that go from 0.87 to 3.9, but most importantly, we have coverage across the entire county. So even if it's actually, let's invert this so it makes a little bit more sense. So the darker areas are places I prefer to walk through. The white areas, like the highways, are ones I really want to avoid, or the water. So from here, we'll go ahead and use that raster calculator in our least cost path analysis. This is going to be our resistance surface, our input raster input surface to create our least cost path.